Hello everyone. Today we are officially starting, this is some bad handwriting, evaluating inverse trig. So let's get started. First thing we're going to do is we're going to graph some stuff. I couldn't figure out how to get graph paper on here, so this is going to get real interesting. Okay, so let's start with our graph of sine. We're going to do a semi-detailed rough sketch. We're going to do a few things on here. So let's say that's 1. That's -1. We'll call this pi and 2 pi. Negative pi. Negative 2 pi. So just a reminder, our graph of sine starts in the middle, goes up, comes back down, goes up. And our graph of sine looks something like this. Fairly rough sketch. That is okay. Now, here's the problem when we are dealing with inverse functions. So when we're evaluating inverse functions, we're no longer solving. We're no longer trying to get the inverse. We already have the inverse. So if I was to, say, graph the inverse, that would be sine inverse of x. We've dealt with inverses for like this entire year now. You know, inverses, you switch your x and your y when you're solving. It's something that you undo. Or when you're graphing, you're also going to switch your x and your y. So I'm going to graph this really tall, short and stout. So we'll say 1 is right there. We'll say -1 is there. I'm just taking my units for my domain and range and switching those. So this is going to be negative pi, -2 pi, pi, and 2 pi. It's kind of funny looking, isn't it? So when I think about this, I go, okay, I know that I start here at, pi over 2. My sine value is 1. It comes back down and goes around, and it looks something, ooh, that's a little off. It looks something like this. Now you may look at this and go, Miss Twain, that is not a function. You're right, it's not. So what we're going to do is we're going to restrict the domain. Ooh, my handwriting, I gotta work on my handwriting on here. We're gonna restrict the domain of sine of x so that when we find the inverse, our sine inverse of x is actually a function. So we're going to do that. And we are going to cut it off. Oop, no, stop, I don't know what just happened. Okay, sorry. We're gonna cut it off here and here. So we're actually going to regraph our sine function just so we can see what that is going to look like. So we're going to have, again, we're going to graph sine of x. However, we're going to be restricting it between negative pi over 2 and pi over 2. That's just me giving the set notation. I'll give the interval notation in just a moment. So it's going to look like this. So here's 1, -1. We're going to say here's pi over 2. Here's negative pi over 2. Our graph is going to go up to here and down to here. That is our full graph. There we go, something like this. That's our full graph. That's it. So when we find the inverse of that, or when we graph the inverse of that, it will actually be a function. So what we have right now is we've restricted our domain to negative pi over 2 to pi over 2. And notice that these are in fact being included in there. Those are closed points. And then our range is going to still just be from -1 to 1. That doesn't make a difference. And if you remember when you are graphing inverses, and I'll do this in a different color so we can keep track. I'll do this in blue. So when we're graphing inverses, we can also just switch our domain and range. So we can say that our domain here is going to be from -1 to 1. That hasn't changed. But our range is going to be from -π/2 to π/2. So our sine inverse, I just realized I forgot to put the inverse. The sine inverse graph, 1, -1, π/2, -π/2 is going to look something like this. So this is our graph of our inverse. Now this is kind of tricky to tell because it's almost looks exactly the same as our original. But what we're going to do is we're going to take these restrictions and look at it on the unit circle to see which quadrants we're really working with. Because what this is telling us right now is that we are only working in 2 quadrants. So let's take a look. Let's actually start in on some of these problems. So let's see. When we are going to practice evaluating, whoops, there we go. So that was just some graphing, just for fun. Evaluate, if I'm going to evaluate something, move this up again. There we go. If I'm going to evaluate something and I just give you sine inverse of 1/2, and you're like, okay, find me what that is. We're just evaluating. Well, there could be a few different answers here, right? Sine is 1/2 in 2 different places, at π/6 and 5π/6. But 5π/6 is not going to fit on here, because if I was to make a unit circle, or a oblong circle, we got a 0 over here. Over here is π/2, and then if we were going backwards, this is -π/2. We only want this stuff right here. We don't want anything else. We want everything from -π/2 to π/2, and there we are. So when sine is 1/2, that's going to be right here. And I know technically there's also an answer in quadrant 2, but we cannot use that answer. We are not allowed to do that because that's not within the correct range. So the only answer here we can have is π/6. Whenever you are dealing with evaluating, there is only ever going to be one answer. It's not like solving where there could be like 8, right? So this is the only time we can have this answer. I know I've been talking a lot, and some people are probably like, whoa, what's going on? So I'm going to write down some of the information I've been saying. So let's see. There are 2 angles, π/6 and 5π/6, that have the y value of 1/2. So that's kind of what this question is asking for. However, comma, sine inverse of x has a range, don't know what happened there, of -π/2 to π/2. So only choose the angle that works for the range. So like I said, all of our answers have to be in that green shaded area, because that's all the information that we have for our sine inverse. So please be careful about that. All right, let's try it again. So let's move that up. So if you were to look at this on a graph, sorry, I meant to do this first. We would be about right here. If you look up above, that's at about 1/2, and you can see that's at about π/6. But now for to do our second example, let's do sine inverse of negative 1/2. Let's do that. So again, I'm going to draw a circle. There we go. Again, I'm going to draw a circle. Ooh, that's a, you know what? We're going to undo that because that's just super not good looking. I don't think that's any better, but I'm not going to redo it again. Okay, so we're just going to do the same thing we did before. Here's 0. Here's pi over 2. Negative pi over 2. We just want this area. So whenever I'm doing a problem like this for sine, it really helps me to just re-sketch this very quickly so I know, hey, all of my answers should be in that green space. So here's the thing. I'm like, okay, I need something in that green space. Right here is going to be my answer, negative 1/2. That's 11 pi over 6. I got it. False. 11 pi over 6 does not fit inside that range. So I want you to be careful. I'm going to make another note. Write any quadrant 4 answers, or quadrant 4 angles, let's say that, as negative. So because we're looking at this fourth quadrant right here, this is negative pi over 2 to 0. So instead of having this be at 11 pi over 6, we're actually going to go backwards, and we're going to say this is at negative pi over 6. So just, again, we're not going to say that sine inverse of negative 1/2. That's not going to be 11 pi over 6. We need to find the negative version or the negative coterminal angle. So what we will say is that sine inverse of negative 1/2 is negative pi over 6. And that is the answer that I'm looking for. So please, please, please be careful. So you may be looking through this and going, Ms. Twain, what about our other functions? And I would say, good, excellent question. We're going to take a look at some cosine stuff, and then we're going to do a little bit of tangent, and then we'll leave the other 3 for next week. Also, if you've been listening this long, thank you very much. Our secret word of the day is stardust. So I'm going to have you share that with me next week at the beginning of our Zoom meetings if you are able to join us. Our word of the day is stardust. All right, let's take a look at cosine. Because fun fact, cosine looks different than this. So we're going to, again, quickly rough sketch cosine and cosine inverse. And I'm actually just already going to give you the restriction there. Let's move you up here. All right, so for cosine, you know what, I'm actually going to graph it first, and then I'll erase some stuff so you can see what's happening here. So let's see. Rough sketch. 1, negative 1. Pi. Negative pi. Our graph starts up here. Ooh, that was really not pretty. All right. I'm trying to make this look good, I swear. Oh, goodness. Undo. Oh, look at that. Oh, that's all. You know what? We're going to call that good. Okay. So what we have right here is our cosine graph. But if we were to do, like, the horizontal line test on this, that's not going to work. So we're going to erase this piece of it. Didn't that want to erase for me? How is it stuck on a laser pointer? There we go. Okay, well, I'm not editing that out. All right, so we get... Oops, that's still on the eraser. We get to here. So we end up with the restrictions from 0 to pi, where this part right here is pi over 2. So our domain is going to be from 0 to pi, and then our range, negative 1 to 1. That still hasn't changed. Let's take all the information of this section and switch our x and our y values for when we graph f inverse of x or cosine inverse of x. So just a reminder, this means that my domain is going to be from -1 to 1, and our range is going to be from 0 to pi, so it's going to look something like this. Should hopefully be a little bit cleaner. 1, -1, say that's pi over 2, we'll say that's pi. So here on our original, I'll actually do that in yellow. Here on our original, this is the point 0, 1, which means on our inverse, we have to start at the point 1, 0. So we're going to start here. We're going to go until it meets this point where it crosses an axis at pi over 2 and curve it back around. So this is what our cosine inverse graph looks like. I know these are very sloppy. I'm so sorry. Desmos has some excellent examples if you'd like to go try this on there. But this is where we're going to look. And this is, in fact, in our first two quadrants from 0 to pi. So let's take a look at some examples here. So for my cosine section, let's do some evaluating. Our first problem here is going to be cosine inverse of negative root 3 over 2. Now you might go, okay, negative, cosine is negative in the second and third quadrant, so we're going to get multiple answers there. Well, when I draw this, much better circle. Remember, we only want to go from 0 to pi, so we're going to use all of this up here. We're just dealing in those first two quadrants. So when I think about, hey, where is this happening? Well, we said cosine is negative in the second quadrant. So this is going to be about here-ish. And that angle for us is 5 pi over 6. Don't even need to worry about it. I love it. But just finding something on a unit circle like this, I think we can do a little bit better. So what if we do inverses and also some things that aren't inverses? So just for fun, just for the sake of fun, what if we did cosine inverse of cosine of negative 2 pi over 3. Now, you might say, Ms. Twain, those two just cancel out. It's fine. You just end up with negative 2 pi over 3. But no, we don't. Because negative 2 pi over 3 is not in the range for cosine inverse. So that cannot be an answer for this problem. So I want you to be very, very careful about that. When you're solving, we can cancel. We are not solving right now. We are evaluating. So we're going to redraw our circle. And go, okay, we're going to take this one piece at a time, and we're just going to look at this middle section right here. And yes, I did just find the highlighter. So we're going to just look at this middle section right here. Remember, all of our answers should be up here in our quadrants. So if we just look at cosine of negative 2 pi over 3, that's actually something we can find. So if I start here and I go around 2 pi over 3, we get to here. Actually, I'll leave that in red. And that's going to be at a negative 1/2. Again, you can also think of that as cosine of 4 pi over 3. But like I said, that's not an answer in our green section, so we have to keep going. So I'm going to say this is really cosine inverse of negative 1/2. So we're going to take that previous answer and plug it in there. So if I go, okay, for my cosine inverse function, where do we have a negative 1/2? Oh, that's going to be over here. I understand it looks like a quarter, but it's not. So that's why we can't just cross out the cosine and the cosine inverse, because negative 2 pi over 3, not in our green section. It doesn't work for cosine inverse. So when I plug that in and ask, hey, where is that in my second quadrant? That is in fact going to give us positive 2 pi over 3. So when I finish that entire function, whoops, I'm so sorry, I end up with, and I like to kind of rewrite the original problem when I give my answer, cosine inverse of cosine of negative 2 pi over 3 is going to be 2 pi over 3. And this is the final answer that I'm looking for. Take a moment, breathe it in. Now, like I said, we're going to do just a little bit of tangent. Thank you for sticking with me so far. I very much appreciate it. So we'll do just a little bit more. We're going to rough sketch, graph some stuff. We're going to do one example for tangent, and then we will be done. Move that here. So for tangent, I don't know if I'll have enough space to graph it. I may have to move this up again. Let's see if I do fx is equal to tangent of x. Tangent of x is actually a really nice one to do here, because you're just going from asymptote to asymptote. It already has like a restriction for itself. And this one's also going to be the exact same as sine. We're just going to go from negative pi over 2 to pi over 2, except it's almost the exact same as sine. That was my bad. Please erase those lines underneath, because like I just said, those are where asymptotes are. So you cannot be equal to an asymptote. That was my hand just getting very excited to be writing on here. Sorry. So very, again, rough sketch of a tangent graph. We're going to say pi over 2 is right here. We're going to say negative pi over 2 is right here. And the reason I want to mark those out specifically is because those are where our asymptotes are for tangent. And then we're going to say that 1 is here, and negative 1 is here. Tangent, we start here. We go up. We go here. So technically, the domain here is from, pardon me, I'm going to erase that, because that should be a parenthesis. Negative pi over 2 to pi over 2, because we cannot include those asymptotes. And the range is from negative infinity to infinity. Now, we can't actually see the infinity to negative infinity on our unit circle. We're really only dealing with negative 1 to 1. So that's really the only section that we're going to be looking at. We can still graph the whole thing, but that's what we're really going to be looking at. So if we're taking a gander at f inverse of x, or tangent inverse of x, when we graph that, it's going to be really long. We're going to have pi over 2 up here, negative pi over 2 down here. Again, these are now going to be our vertical asymptotes. It'll look something like this. And then we're going to have 1 and negative 1 with our graph starting here and going onward and going onward. But just like I said earlier, we only really care about this section in the middle right here, which are going to be in quadrants 1 and 4, just like it was for sine. Very convenient. Some of you may think I don't know the definition of the word convenient, but I do, I promise. So, like I said, we're just going to do one example, and then we're done. And this one's going to be fun. This is going to be another, like, function inside of a function. But what if they're two different functions? Can we do that? Of course we can. So for our last example, we are going to do cosine of tangent inverse of the square root of 3. So just keep in mind, if I was to look at a unit circle, we are going to be looking here for our inverse stuff. And our inverse stuff happens to be in the middle. So we're just going to start with the inverse stuff right off the bat. Okay, so let's see. Let's do tangent inverse of the square root of 3 happens, square root of 3 happens 2 places on the unit circle. For tangent, it happens here, and it happens here. But this one in the green section is the only one we care about, and that is at pi over 3. So this is the angle that we're looking at. So first we're finding the angle here, and now we're going to take that, plug that back into cosine, and find the length. So what is the cosine or x value at pi over 3? Oh, that's 1/2. So that's it. Again, only one answer. And when I want your final answer, please rewrite the question. It just helps me follow your work. And this is what we're looking for. Thank you for sticking with me for so long. Just a reminder, the special word for this lesson is stardust. Please give that to me next week. I hope you have a good and relaxing weekend. I would love to hear from you soon. Goodbye.